A quick video going over these questions that I've posted in the slideshow for review. So when we look at a niche map for an individual, what we're really particularly looking for in terms of the optimal realized niche, which is where the species would actually live based on its optimal environments. What we're really looking for is a concentrated color of dark blue and dark green because that's effectively showing us where in the United States are there environments where this species thrives. So for the first parameter, which is inches and temperature, I would be highlighting this area of like 30 to 60 and 50 to 44. I would be identifying, somewhere in the soil productivity of 7 to 11 and an aridity between 1, 0 and 0.2. And definitely for clay levels below 18 and between percent sand of about 40 to 80%. Now, it is of note that for this tree, it also can do really high clay levels and really low sand levels. Generally, what I'm getting from this in terms of the red maple is that it's a pretty strong generalist with a tendency to be slightly restrictive with soil productivity. It tends to like slightly average soil, and it likes reasonably wet soil based on these positive aridity values. A reminder that precipitation is rainfall, and it increases as you move closer to the equator or move down in elevation. Same with temperature, it increases towards the equator. Soil productivity is just a measurement of how good your soil is. A 1 means that it's 100% sand. 17 is a loam. Sand obviously makes soil more porous. Clay makes it hold on to water better. When we look at the red maple, we have two different importance values. We have, I believe, average rainfall between May and September, and we have average pH. And what we're really looking for is, are there strong color overlaps when we look at these two? And from what I can tell, it does appear that soil pH is a little bit more important. It looks like this tree really likes a dark red soil pH. Notice in New Hampshire and Maine, we have dark red. In Pennsylvania, dark red over here. But also at the same time, notice dark red in the Adirondacks. It's not as useful. Alternatively, if we go over here, we look at wet areas, and sometimes, say over in Western New York, it's quite good for the maple. And at other points, we go here, mid-central New Hampshire, and they're lacking. So both are important, but I don't think, again, getting into analyzing this, both aren't perfect predictors, right? There's more than one thing that influences whether or not a tree lives in a particular area. I do think it is of note that when we get into Pennsylvania, the rainfall decreases, but the soil pH is more acidic. But then when we see that same acidity in the Adirondacks, there's fewer trees and there's more rain. So generally, it looks like the red maple enjoys moderate levels of rainfall and moderate levels of pH. It's showing that it tends to be a generalist with lots of flexibility in its niche. If we look at a soil pyramid, 42% clay would be going across here, right at 42. And then silt would be 38%, so we go down. So it looks like we are in clay territory. And then sand is 20%. We go up, bingo. So this is clay. This means that it would have high nutrients, it would hold water really well, but it would freeze quickly, and it might create root rot because of all of that water. When I look at the climograph, what we're looking at is seasonality with temperature, right? The greater the change in the temperature from winter to summer, the more likely that we're seeing a location further away from the equator. Anytime you have a temperature above 0 degrees Celsius or 32 degrees Fahrenheit, it means that you can have plant growth. 1, 2, 3, 4, 5, 6, 7, 8 months of plant growth. And then obviously, the more rainfall you have, the more NPP you can have because of sunlight and rainfall increasing primary productivity. In terms of Stowe, we're at 45 degrees above the equator, which helps explain why we have cold winters and warm summers. We're only 600 feet above sea level, so it explains why we don't get too cold and we have quite a bit of rain. I think the seasonal spike in rainfall is because of the increased temperatures making evaporation increase. If we made Stowe close to 4,000 feet above sea level or 1,300 meters above sea level, we would probably see the summers be less cold or less warm, sorry. The winters would be colder and generally precipitation would be lower. If we went down to a latitude of 30 degrees north, so we were closer to the equator, our summers would be warmer, our winters would be less cold, and we generally would have more rainfall. And if we were next to the ocean, more precipitation, and the temperatures, because of water making colds less cold and warms less warm, we would see a smaller temperature curve. Remember, if we go back, way back in time, we learned that water is really good at regulating temperature. All right, let's go back. When we look at population curves, R-selected species grow faster than K-selected because they tend to have shorter lives, they have more babies, they are generalists, and they reach sexual maturity quicker, so they're less dependent on the carrying capacity. They have less density-dependent factors that limit them. K-selected species are specialists that grow slow. They have more specific needs, so they tend to be more influenced by density-dependent factors like space, resources, competition, disease. So that's why they tend to slow and stop their rate of growth as they reach that carrying capacity. I would describe R-selected species as a generalist, and I would describe K-selected species generally as a specialist. Once this specialist reaches K, or the equilibrium point, that's where disease might make a population go down. It might mean lack of food or resources makes the population go down. It might mean competition increases, so the population goes down. Things are making this population no longer able to add. And then when we get to these three factors, clumped species are likely specialists because they have very specific resources such as territory, space, or social structures that they need in order to survive. They tend to be type 1 because they have paternal and maternal care. So because they live in a packed area, they're limited by resources. So they don't have many offspring. Notice there's 1 or 2 baby elephants in this herd. They're density dependent because they generally are large. They need a lot of calories. They need a lot of space. It means that they can't just have infinite numbers of individuals in their population. Random individuals are generalists because they can grow anywhere. Like a flower releases pollen and it's just going to go anywhere in any direction, and if there's available space, it will grow. And they're type 3 because they make lots of babies, right? You know this from allergies in the fall. When a tree makes pollen, that each of those little pollen seeds that cover your car in dust is one potential offspring. So they're making millions of babies, and only a few of them are going to survive. A good example of density independent limits to growth would be mowing this lawn, right? It does not matter how many dandelions are in this lawn. If I mow it, which is a disturbance, it's going to impact all of the dandelions equally. So remember, density independent means that the amount in an environment doesn't matter. It's just going to be a disturbance that impacts all of the individuals regardless. Uniform species are somewhere in the middle. Birds are a good example of this. They have some space and territory requirements, but they're not as dependent as elephants. They tend to have larger populations, but they don't have offspring in the same Why aren't we going back in time? They don't have as many offspring as, flowers or insects. So they're somewhere in the middle, but they maintain this uniform dispersal because they do have some requirements that are stronger than just randomly growing in the middle of a field. So I hope this video has been helpful. This isn't going to be everything on the test, and some of these things might not be on the test, but I think it's a good comprehensive overview. Email me if you have any questions. Have a good day.